Hello everyone, welcome to Simulation. I'm your host Alan Sakian, and today we're sitting down with Klee Irwin. What's up?
How you doing?
Yeah, I'm doing fantastic. I'm very grateful to have you on.
Good.
I think everyone's going to have a blast on this one. Klee's background is super interesting. He's a founder of Quantum Gravity Research, and he is also an associate founder at Singularity University, an investor in companies like Moon Express, Upworthy, Change.org. So we're going to be diving into reality, we're going to be diving into physics, we're going to be diving into maximizing human potential, all these cool consciousness, just we're gonna have a good time. This is gonna be a blast.
That's right.
Yes, and guys, for you tuning in at home, if you guys want to get exclusive content, if you want to get access to chatting with our speakers, get access to exclusive video, access to live events ahead of time, all that good stuff, check us out on Patreon. The link's in the bio. All right, so let's talk about your background, Klee, because you are autodidactic. You're self-taught, right? How have you been doing that over the last decade or so?
Oh, well, I think I have ADD. So basically, learning something in a rote fashion, I can't get my mind to track it for very long, because as soon as I get into it, my mind branches out and starts synthesizing my own extrapolations, right? So when I got out of high school, I started college, but basically a couple years after starting college, I just had all these ideas on how to make money and build companies. So I just dove in and maxed out my credit cards and joined the entrepreneurial adventure. And
we are the same in that sense.
Yeah.
We are the exact same in that sense.
And so anyway, and so then in business, I'm a fast learner because with ADD, since you can't pay attention to that which is boring for very long, you better figure things out and synthesize your model of what's going on in the world or in a situation quickly. So you put things together quickly while your short attention span is there. And then conversely, you have this ability to focus in obsessively like a laser on that which stimulates you or interests you. So with entrepreneurialism, we grew very rapidly. We figured out how to eclipse the competition in our industry at the time, which was nutraceuticals, herbal and vitamin supplements for treating, various health goals. So then we became a publicly traded company, and I had to learn very rapidly the technical details of this industry, the legal details, and how to deal with a company that grows very fast and exceeds 100 employees in a very short period of time, and where you have new HR things, all sorts of new challenges. So anyway, so I went through that learning process. And I think creativity is key in business, obviously. And creativity is about how rapidly you can synthesize different combinatorics of ideas and innovate and solve problems. And so somehow my mindset of creativity and short attention span for that which is boring, counterbalanced by laser-like obsession to that which interests me.
Yes.
That worked. And then after 15 years of doing that, I got a sort of mission, right? And my mission was about philanthropy. So I met Peter Diamandis, and he said, "Have you ever thought about philanthropy?" And I said, "What's philanthropy?" Almost, right? I had not thought about philanthropy because as an entrepreneur starting in your 20s, you work 80 hours a week, and you can't put your head above water to even think about anything.
Yes.
So anyway, then Peter really got me thinking about it. I went to this meeting. Aubrey de Grey was there, and about director of NASA's Ames Research Center, Pete Worden, and a whole bunch of other cool people like Larry Page were there. And I really got inspired by these people who want to use their money and their technological and innovation abilities to help do good in the world, and not just rely on governments or others in power to do it, but to go out and try to address the problem with the entrepreneurial mindset, really. So then I came back to Los Angeles. That was at the Ames Center at Moffett Field. And
what year was that?
That was let's say about 9 years ago.
Okay.
And so then I came back to LA, and I started thinking, wow, so how can I give back? How can I do something that does good in the world besides making money? Because as an entrepreneur, you're focused on, to me, entrepreneurs, they're focused on the game. So it's not just about making money. It's just like Monopoly. It's about innovating and being creative and growing and competing. And so I thought, well, how can I take that innovation and think big, like high impact, world changing ideas? And so really I just gravitated toward fundamental physics, because it seems to me that all of the sciences, from genetics to quantum computing, everything really is like an upside down pyramid, resting on the most simple aspects of reality, which is where there lives a grand problem that hasn't been resolved yet, which is, well, how does this theory of space and time, general relativity, how does it live and agree with this theory of everything else, which is quantum mechanics? Because both of those theories imply that the other is incorrect in real deep and serious ways. And so perhaps if we had that underlying unification theory, it would lead to a golden age of rapid technological improvements, which could help the world, especially with suffering. I mean, having more convenient gadgets is cool, but to really take care of the third of the world or so that is suffering, right, because of lack of resources, that's exciting. So I put my mind to that, and have been doing that now for going on 10 years. I walked up to my assistant's desk and I said, "Hey, Stephanie, I'm gonna quit life as a businessman and go and try to solve the theory of everything. Do you want to come?" And so we walked out of the building and never went back. And so the company still exists, but I am not very involved with it. I work full-time leading a group of about probably 18 or 20 people who are working on these fundamental physics questions in three companies, actually. One is an experimental group working on cold fusion, which is nowadays called low-energy nuclear reactions. Another experimental group, both of these are in Silicon Beach in Los Angeles. And the second group works on topological quantum computing. And then the third group was the first group, the theoretical group, working on the unification physics story. So the two tech companies are essentially taking theoretic predictions from the quantum gravity unification group, and then going out and trying to create world-changing technologies, high risk, high reward companies, because you're in the sector of energy, clean energy, and you're in the sector of quantum computing, which is a big wild card, because nobody knows how quantum computing will change the world.
Holy cow. You are a man of incredible past and present, and I love your drive for now philanthropy and your drive for understanding the unification theory. I'm in awe. And I really appreciate that 9 years ago, though, that moment for you of how can I help make the world better. In our conversation with Jordan Peterson on just Saturday the 17th. We were talking about competence and how the people that have high amounts of competence actually really love helping other people.
Yeah. It's fun and it's rewarding, and it just seems like once you catch the bug of doing good in the world, it becomes a way of life, and you look back and you say, wow, how was I just living a mostly selfish, ambition? Because you can have both. You can take care of your needs and your family needs, and do massive good in the world. So I really have to say again, I credit Peter Diamandis for triggering that, and all the other guys and women who were at that first meeting where we talked about starting Singularity University. I mean, they really honestly inspired me in a big way. So.
Yeah. And now you guys are all off and inspiring people through tons of different mediums, including Singularity University as well as your research institute. So, all right, so I kind of want to start a little bit to your past because you were describing how you really loved doing your laser-like focus on the things that you cared about. And that seemed to be the most kind of fundamental principle of your 20s and your entrepreneurial passion.
Right.
There seems to be a lot of people that are around this age group or that are living life right now in their entrepreneurial time zone that are kind of following a similar mindset of how do I focus on the thing that I love doing, how do I kind of let the other things be and really hone in, and how do I bring that to the world? What maybe recommendations would you have for that?
Wow, I'll tell you, I get asked this question. So there are a group of people who ask me this question and they know what their mission and their passion is. And then there are other people who ask me that same question and they don't know. And they say, so Klee, how do you find out what your highest purpose is, or your passion or your mission? Because I'm interested in 3 or 4 things and I really don't know yet. And I mean, perhaps it comes when it comes, because for me, it just came like a lightning bolt. I didn't try to conjure up this clarity. It just happened. And when it happened, I knew I can't go back to this old life as a businessman where my only thing is just contracts and marketing and sales and the whole process of running a mid-sized company. But I do think that you can also search, like the Native American kind of quest, to find out when you become a teenager what your mission is. I think that you can simply say, I'm going to go inwards, or I'm going to go on a retreat, or I'm going to just think. Maybe go to inspiring things, like for me, going to Singularity University's first discussion meeting before there was a Singularity. For me, that kicked it off. But I say just seek and try to tune into this abstract idea called intuition. Because if you get too mental and calculating about it, it's probably not your true mission or passion. It has to be this element of feeling it in your gut, like your inner knowing or intuition.
Yeah, and then how did you follow along with the laser-like focus as well?
Oh, the laser-like focus just comes naturally for me. And I suppose that it may come naturally for anyone who's doing what their calling is or what their passion is. If they're freed up to do that and can make money doing that, then I think the laser-like focus might just come naturally, because if you can, it's a cliche thing to say, but if you can go to work to play every day, I'm going to play.
Exactly.
It's
not even work.
Right.
It's life.
Yeah.
It's love.
Right.
Yeah.
Right.
So, okay. Good. All right. And then you jumped right into where I think we should probably go next, which is I kind of wanted to talk about philanthropy as well. Maybe it seems like let's go in this order. So about 9 years ago, when you guys were having those conversations about bringing good to the world, and then you ended up starting quantum gravity research, but and then simultaneously you ended up helping with organization like X Prize and
Yep.
Change.org and other Moon Express, etc.
Yes.
along this path. So maybe we talk just a bit before we get to all of the quantum mechanics and unification theory. Let's talk about kind of this prize model. It seems to be what is exciting for so many people is a big offer of a prize to solve a global challenge, and then people pool in their resources, their time, and their money to try and solve that problem and earn that prize money. It seems to be eliciting a lot of innovation, that model.
I'm certainly no expert on it. I did end up kind of having a serendipitous chain of events that related to X Prize. I took my daughter for her 10th birthday on one of the Zero-G flights, which was a company that Peter had co-founded. And so me and my daughter, we went up and we escaped Earth's gravity for 15 times for 30 seconds of weightlessness each time, and it was an awesome experience. And then it was there that I met Peter, who was also working that day on the flight. And then he asked me if I would do some pro bono marketing consulting for him at X Prize Foundation, which was in Santa Monica at the time. And I go and I do that and give him all my 2 cents of marketing advice. And then he says, "Hey, have you ever read The Singularity is Near? This book really made an impact on me." So I said, "No." I went and I read it, and that book made an impact on me. I don't agree with all of Ray Kurzweil's take on things, but I agree with the notion of exponential change and emergence. And so then, from what I came to appreciate about the prize model is back to the word fun. So you look like you're having fun what you're doing, so you go to work every day to play. And so if you can turn research and development from the very heavy idea of corporate competition and lose your job or lose your company or lose your stock value if you fail, or academics with all of its politics and often constriction of outside the box ideas, if you can turn it into a big gamified competition in a prize, then obviously where there is fun, there is more creativity, and boom, then you've got outside the box ideas, and every once in a while one of those outside the box ideas that comes from the creativity of play changes the world. So I think it's I don't think it's a trend or a fad that's going to go away. I think that that this gamified model of prizes for R&D is we're just seeing the beginning of it.
Yeah. I love how you keep bringing up play, and play being the central theme of life, dancing through the fabric of space-time and really enjoying whatever you do every day to the extent where it doesn't feel like work, where it feels like fun and play, and that's kind of where your actualization, your essence will come from, as well as helping the world will come from that as well. Okay, so emergence theory.
Yes.
You gave us a little taste at the beginning when you talked about an upside down triangle.
Yes.
You gave us a little taste of that. So this has been your last about 9 years of research into that. I think people are familiar with the word quark. Seems to be the most smallest thing that we can discuss. And then interestingly enough, the largest thing we can discuss, a universe, and then between those two things is apparently a human. Right in the middle. So interesting. So maybe what is this, this quark and this emergence theory? How does quantum mechanics relate with that, your research?
Okay.
Start us from the beginning.
Well, okay, so let's think of the idea of pixelation. So we can have a nice 4K video monitor that has fluidic patterns and smoothness playing at some frame rate, and you'd have no idea that the frame rate is actually underneath what appears to be continuous time and continuous motion. That between the steps of motion on this 4K video monitor, a particle moving from here to here, it doesn't traverse the infinity of steps between here and here at the pixelated level of frame by frame time and pixel by pixel position change. If you zoom in small enough to time and small enough to the space of your pixels on your monitor, you will see that the smoothness of smooth time and smooth space was illusionary. So quantum mechanics is part of the story, and it gives us clues about nature, as though Mother Nature is whispering in our ear, I am pixelated down to the core in every way, including space and time. Now, what we know so far as a consensus view is that nature is pixelated in terms of things like spin. So a particle can have either spin up or spin down. And we have a quantum of angular momentum, we have these quanta of these actions in particle physics. So in some sense, it's a pixelated view, but we haven't gone so far yet as to agree that even space and time, where these particles play out, is a pixelated reality. And so the search for quantum gravity means the search to unify quantum mechanics, which tells you everything about particle physics, and the theory of space and time, Einstein's general relativity. They don't yet fit together, and part of the reason is because the theory of general relativity makes a conjecture or an axiomatic choice with no proof that space is smooth, so that between any two moments there are an infinity of other moments, not pixelated, and that space, so space and time, are smooth. And so that this quantum mechanics and particle physics plays out in this absolute smoothness. But if that weren't the case, and that somehow at this very smallest scale of reality, which is called the Planck scale, which is actually a length and a volume and a time implied by quantum mechanics.
Yes, Planck.
The Planck time,
yes.
The Planck volume.
Yes.
So then it's so fantastically small, it's well beyond the ability of our particle accelerators or any possible current technology to zoom in to that level where the Planck length and volume and time are. So all one can do is speculate. So we can speculate and make a choice with logic that either space and time are pixelated, like your video monitor, or they're smooth, like the common sense, more ancient paradigm of this smoothness. Like it seems smooth. So, I mean, it wasn't 100 years ago when people actually thought water was a continuously smooth medium. And then it was found out that it was pixelated with these little clusters called H2O molecules. But only 100 years ago or so, that was not known to be true. Einstein actually proved in 1905 that molecules exist, you know, in one of his three famous papers that he wrote in that miracle year. And so anyway, so what we're doing at Quantum Gravity Research is we're part of a community of physicists around the world who are working on this idea of quantized or pixelated space-time. Our approach is different than the other popular approaches to that. And so here's where it could get a little complicated, but hopefully not too much so. So the most expensive thing that humans have ever built is the Large Hadron Collider in Geneva, Switzerland. Not only is it the most expensive thing, it's also the largest thing, 27 miles. It's also the most technologically sophisticated thing. That Large Hadron Collider is the epitome of mankind's highest technology in various fields. And what is that big thing? And who paid for it? Well, it was so expensive that one country couldn't even get taxpayer dollars to afford it. So people pitched in right? Various nations pitched in and paid for this thing. And all it is a microscope. It's a giant microscope to peer down as close to the direction of this pixelated Planck scale of reality that we can peer for the purpose of understanding unification physics. And because it's generally believed that if mankind discovers this unification theory, it will usher in a new golden age of rapidly advancing technology. Perhaps it could usher in Star Trek level technology 200 years early. So that's why governments paid the money for this giant microscope. And what have we gotten from this giant microscope and the earlier lower resolutions before that, like the SLAC here in Stanford? Well, what we've gotten is a bunch of numbers, and those come by colliding particles together at high energy. And those numbers...
Typically, which particles are we colliding?
Neutrons, for example, will be collided together, and then you'll see, in the collision, you'll see these angles and these particle transformations occur. So a bunch of data from smashing particles together. And that data has been assembled into this model, which is an extension of the theory of quantum mechanics combined with all this particle accelerator data that is called the Standard Model of Particle Physics. And I think a lot of physicists would agree it's the most sophisticated and powerful physical model that mankind has so far. So it explains everything except the theory of space and time, gravity, that is, gravitational theory. And so one interesting thing about this standard model of particle physics that we have as a result of machines like the Large Hadron Collider is, for some reason, the way all these fundamental particles and forces, except for gravity, convert into one another is according to these higher dimensional crystals and algebras. So they're called Lie algebras, and a given Lie algebra has an associated geometric object, which is a higher dimensional crystal or lattice. So
that the particle is made up of?
No, it's a mathematical thing. So let's say that, so we understand from the standard model how a photon can become a neutrino, which can become an electron, which can become a quark, and how all these things, this zoo, or a small set of fundamental irreducible particles, how one can become the others. And so it's a unification model. So it's unifying all particles and forces, the standard model, with full compliance with quantum mechanics, except for gravity. It doesn't know what to do with gravity. So it's a unification model. And for some reason, the mathematics of how all these things interconvert or transform into the others and unify maps to the vertices of these higher dimensional polytopes, shapes. So think of Platonic solid shapes that are in higher dimension, like a tesseract is a four-dimensional cube. So these higher dimensional shapes, which map to these higher dimensional algebras called Lie algebras, and the shapes map to these crystals, just the way a cube would map to a cubic crystal, right? Or a square lattice on some grid paper is made of squares. So that's the polytope, and the lattice is just a repeating of that shape. So why does reality relate to these higher dimensional shapes? Why mathematically is that true? We don't know. So nobody knows deeply why that is. But it is the case, and it's non-controversial. What's controversial is when people try to bring gravity and space-time theory into it, because there's no mathematically convincing argument for that, which a consensus of people agree on. But we know that everything else maps to these, strangely, to these higher dimensional shapes and crystals. And so what we do is we take one of those higher dimensional crystals and we project it mathematically, like this here. We're projecting it to the wall. So this is in 3D, and as it goes to the wall, angles get rearranged, lengths get shorter, and we have a transformation. But the shadow encodes everything here. So if you knew how to do the trigonometry, you could take that shadow and reverse engineer it and say, not only was the light at this exact angle to the object, but here's the description of the object, just from the lower dimensional shadow. So what a quasi-crystal is it is an irrational projection, right, of a higher dimensional crystal. So we take the E8 lattice or crystal and we project a slice of it mathematically to lower dimensions, 4D and 3D, and we get an object, which is the shadow or the projection, called a quasi-crystal. And a quasi-crystal is a great way to pixelate space-time because it's a code. So a crystal is not really a code because you have no freedom.
Now I think I'm connected. Pixelate space-time.
Yes.
That's okay. Because so much of this is over my head because you've obviously been studying it for so long. I'm trying to keep up and follow through. So let's loop back to that start and then let's get back to this crystal. Okay, so pixelation of space-time.
Right.
We do think that is what is going on, or we don't think that.
So we're part of a community of people who are working on quantum gravity theories. So most people working on quantum gravity, or many of them, are presuming that space and time are pixelated. Now that's not a technical term. That's just, we use the word quantized or discretized, but it's the same as the word pixelated.
And it's more relatable, I think, for people because they know the pixels on their devices and stuff like that. So in pixelation of space-time would be down to this level of the Planck length, is that?
Exactly, so the pixels would be little volumes, so it would be the Planck volume, and time would just be different. So
the Planck volume, okay, and would that be where the lattice, this crystal is at?
Yes, that's where the quasi-crystal is at. Okay. And the interesting thing about quasi-crystals is they are languages, geometric codes. For example, if I give you the black and white and red squares to make a checkerboard, it's not a code because you have to put it together exactly the way it needs to be put together to make the checkerboard. So you have no freedom, syntax freedom to express any patterns in there. It's not a code. Crystals are not codes. But quasi-crystals are codes because how they're assembled comes with rules. So you have a set of shapes, and then you have rules on how you can arrange the shapes. And then within the rules, you have some syntactical freedom. So you can match this like this, or you can match this like this. So you have freedom. And once you have syntax or freedom in a set of ordering rules, like English, then you can express all sorts of meaning.
Okay, so at the Planck length, we have a quasi-crystal.
Yeah.
And then at that level, we have the checkerboard can only be arranged in the way that the checkerboard makes sense, but the quasi-crystal also can't be.
That has the freedom.
It has the freedom
Yes.
to be arranged in, and so this is kind of the upside down pyramid.
Well, this would be the bottom of the pyramid. So this would be, if it's real, then this would be what we call a first principles unification theory. So first principles means that when we take Einstein's general theory of relativity, or we take the standard model that I mentioned as the most advanced theory we have these things called free parameters, which come from things we observe, but where we don't know why they are the values they are. For example, the gravitational constant, or the electron rest mass. So we get these values that we get from measurements, and with measurements we never know with full accuracy what the real measurement is. We just get approximations because the fidelity, right, of our equipment is always limited. And so with most models, well, with all models really, physical models, you take a free parameter that you get from your observables. In the standard model, there are 20 free parameters, just things you plug in, and then you work the math around that. So the model itself never explains why the values are. Like we don't know today why the speed of light has the magnitude it has. For example, that's a great example. So if first principles unification theory would give you the speed of light and tell you why it has the magnitude it has from first principles. So this would be this idea, this story I'm sharing at the bottom of the pyramid of all of physical sciences would be this code, a geometric language that comes from these higher dimensional lattices, which are already known to encode realistic unification physics, except for gravity, and by
things like particles.
All the particles and forces, right?
Okay.
Electromagnetism, right? Everything except for gravitational theory. So now there are people who tried it.
We're bringing that down to the Planck now.
So we just mathematically say to get the code, we take this higher dimensional thing because like the shadow on the wall, with the lower dimensional projection, you can recover or decode, you can recover, unfold all of the information of the higher dimensional thing. So if we have, it's called gauge symmetry unification physics. That's the standard model of particle physics. Everything explained with gauge symmetry except for gravity. So if we simply rework the math by projecting the hyperlattice slice down to a lower dimension, we can recover within the mathematics of the projection, which is the quasi-crystal, we can recover the gauge symmetry unification physics. That's not a problem. The challenge is to understand the code, right? Because the quasi-crystal, if I give you the rules for a quasi-crystal and give you a few tiles of it, of a two-dimensional, for example, quasi-crystal, you would easily learn how to play with those rules and build some nice patterns, and you would have an understanding of your syntactical freedom. So if I gave you only 8 tiles of, there's a famous quasi-crystal called the Penrose tiling. It's just a two-dimensional tiling. It's actually the tiles that you would see on a Muslim mosque.
Okay.
It's those tilings made with a few simple shapes. And you might discover with only 8 tiles and following the rules, you might say, hey, Klee, it looks like I can have 5 different ways I can arrange these 8 tiles. And I would say exactly. Now, if you do the 5 arrangements in a certain order, you can make a pattern, like an animation, if you were to play those 5, one after the other. Just like on your video monitor, if you were to play at 24 frames per second, frozen images changing on your pixelated screen, you can create the illusion of particles or movement.
Okay, I've probably never felt like a 3-year-old more than I do right now, trying to understand something that's so damn complicated and interesting and so important for humanity. So let's pixelate space-time, and then let's say that at the very, very smallest pixelation is the Planck length,
right.
And that whatever we understand that we've done with like the Large Hadron Collider with particle physics, now we're trying to bring that similar style of math and geometric understanding to the Planck length.
Exactly. We get all that for free by taking our projection from the E8 lattice. Then we have the unification physics that people have done on the lower dimensional lattices that live inside E8, or people like Garrett Lisi who do work on E8 and others. String theory, original string theory was done with 2 copies of E8, for example. So we get all of that for free. What we're working on now, this year, is exactly what is the nature of the code and how do these are called quasi-particles. So when I said you have those 5 ways that you can arrange it, if you make an arrangement in a certain way that makes an illusionary pattern, like a propagating blip, right? That would be called a quasi-particle. So we would say in physics, the things we call particles are actually these illusionary quasi-particles that come from ordered patterns, ordered sets of these legal configurations of the quasi-crystal, because you can make it in several ways. And so that's what we're working on now. And of course, the big issue is, so how do we bring in the theory of space and time and gravity into this picture? And that's that's the grand challenge that no one has figured out yet in a way that makes predictions and gets a consensus within the scientific community.
The unification theory is going to drive, like you said, an acceleration to the Star Trek future,
Right.
and I love people that are diving into this face first and understanding it better. And it's so amazing to learn from you along your journey right now. Okay, so that's the. Let's chunk up what you're doing at Quantum Gravity Research. So we have the unification theory.
Yes.
We're pushing for that, and then we have a couple other pushes as well. So
Yep. So
quantum computing is one of them.
Yes.
And then the other one is the cold fusion.
That's right.
Okay.
So these are two startup companies in Silicon Beach, Los Angeles.
I love calling it Silicon Beach, by the way.
I do too. And
it is what it is. I love it, yeah.
And so they're, in some sense, they're separate companies, but in some sense, if they were part of quantum gravity research, we would call them experimental divisions, right? So those would be the people, the scientists, trying to test out a theoretical experimental prediction of the people in the theoretical group. So we got this idea that you can use this quasi-crystal mathematics and material science, because quasi-crystals physically exist in nature. They were discovered in 1984 to be physical phases of matter that are possible. Prior to 84, it was believed it was impossible for them to exist. Physical quasi-crystals, they have a lot of interesting anomalies. So there's photonic anomalies, thermodynamic anomalies. So an anomaly just means something that you observe experimentally that the best theories of the day say cannot possibly be true. And since experiment always trumps theory, when it's clearly experimentally evident, even if it has no theory that says that it's okay, it's called an anomaly. So it's an orphan observable fact because it has no parent theory to allow it to be true, and yet it's true. So we have all these anomalies in atomic scale, physical quasi-crystals, and so we're using these mathematically abstract quasi-crystals for the mathematics at the Planck scale, and so at Emergence, which is the quantum computing company, we're using physical quasi-crystals to build an ideal topological quantum computer. So no one has built a topological quantum computer. So Kitiev at Caltech.
What's the difference between quantum computing and topological quantum computing?
Well, they're both quantum computing, and topological quantum computers would be quantum computing that you do with a topological phase of matter. And a topological phase of matter is any phase of matter that is massively entangled. So your quantum entanglement reaches a threshold where it displays these qualities which define it as a topological phase of matter. It's called the fractional quantum Hall effect. But really what it means is that the matter is exquisitely and massively entangled or connected in bizarre ways, because quantum mechanics is bizarre. It's just non-local, non-intuitive, non-normal. And so these are exotic phases of matter, and Kitiev at Caltech theorized some years ago that you could build a topological quantum computer. And so you have this space race going on with Google, Intel, Microsoft, China, IBM, and pretty much all the major players in the field are pursuing non-topological quantum computing, except for Microsoft. So Microsoft stands as the sort of lone wolf of the big guys because they're gambling on the idea that Kitiev's idea of topological quantum computing is the ideal quantum computer. Because Because with nature we have limits, right? There's a limit to how fast something can go, for example, in the speed of light. And so logically there should be a limit for a given amount of mass of how much quantum computation nature would allow in, say, 1 second. But because we don't really deeply understand the theory of quantum computing yet, and we don't even really deeply understand quantum mechanics, for that matter, science as a whole. Richard Feynman famously said, "I think it is safe to say that no one understands quantum mechanics." Not really. Mm-hmm. So anyway, no one's succeeded. Microsoft hasn't succeeded in actually building a topological quantum computer, and there has been in recent years some limited success in building very small and not so helpful quantum computers, not topological quantum computers. So there's this sort of space race to figure out who's the company who can come up with a powerful and helpful quantum computer that changes the world first. And it's a race, in a way, unlike the space race going to the moon, where we're really just using technologies that were understood, and it was a race to see who can take things that we understand and build machines quick enough to go to the moon. But in this race for this idea called quantum supremacy, which is the buzzword name for the race, it's the race that involves a lot of unknowns because we don't deeply understand this regime of where quantum mechanics and material science and perhaps even quantum gravity all interplay. And so there's a lot of theoretical speculation and creativity in this race. So we are a way smaller group, but maybe we get lucky and we have an outside-the-box innovation that gives us a sort of inside track to maybe having a David and Goliath story with the big boys.
And I love the term quantum supremacy, because then there's also AI supremacy and genetic engineering supremacy, Mars supremacy, whatever other supremacy there is. Maybe you kind of give us a quick idea into what you think's going on with the whole geopolitical sphere with these racist supremacies. Do you think that how we need to actually work together?
Yes.
Or
in terms of the interaction between the different technological races?
And different countries and in the races.
Well, that's a great question because for me, innovation is about combinatorics, right? That's about combining ideas. So this guy over here did this experiment and we heard about that proves that this is possible, and then this woman over here did this paper on this theory and they seem unrelated, but what if they're related? And then you realize, oh my God, they're totally related. So it's about combining, right? And if you put up walls to block the connectivity of a neural network or a network on the Internet of Minds or a scientific community, because, for example, let's say you're in the Trump administration and you believe that too much collaboration and allowing scientists from other countries to come here is stealing American jobs, and that's your only mindset, then you cut off collaboration and mixing things for better combinatorics. So you cut off your nose despite your face.
Combinatorics. Very interesting. Similar to how I discuss, I guess, polymathic disciplines or interdisciplinary research, things like that.
Right.
Combinatorics, because whatever they're researching right now about AI or quantum computing or genetic engineering in China or Russia or wherever could be worked with the US's research or with whatever other countries' research and made into something better than what it is.
And
right now.
Cross-disciplinary. So even within a university, you tend to have silos where this department doesn't do a lot of interaction with this. So, for example, here's a fun party trick. You're at a wedding, and you're running the wedding, and you're trying to plan these 16-seat round tables, and you have this one special table where you've got, the bride and groom's parents and brothers and sisters, and there's 16 people. And you want to arrange the name cards around the table so that when they all come to sit down, they enjoy themselves with lively conversations, right? So you're thinking about all the ways that you can combine these 16 people around the table. Most people wouldn't guess that the number of combinatorics of ways you could arrange just 16 people around a table is almost 22 trillion with a T. So when it comes to combinatorics of ideas, it's a nearly infinite set of combinatorics with the large amount of ideas that we have. So what we don't want to do is cut off the connectivity of the neural network of minds. We want to allow the free-flowing connectivity, and through our politics, our ways of engineering our societies, we need to open that up. We'll all be better off in the end. We'll be more prosperous.
Wow.
Jobs will be better, but if you cut off the connections because you think that in the near term you're going to save a job or outcompete or something, better to
That
be
seems to be
open
the
source.
biggest one. The biggest one is the concern of competition.
Right.
That's the biggest one right
Right.
now. That is siloing people off of one another.
Yeah.
But I really love your perspective about combinatorics and open sourcing the collaboration across disciplines and across countries.
Yeah.
I love that. I do think that that's without a doubt going to be the future.
Yes.
But I think right now there's so much discussion about competition that is
Right.
holding people back from that.
Right.
Yeah. So, and we can dive deeper into that, but I want to just cycle quickly back to quantum computing. Explained at the most basic level, is it the ability to leverage quantum mechanics for computing?
Yes. There are various ways to think about it. Perhaps imagine if reality were similar to this story that I've been sharing with you, where there isn't actually smooth motion, that what you perceive as motion is these frozen states, frozen quasi-crystal frames at the Planck scale, and that the frame rate is so fast. So the frame rate, if it were the Planck time, would be happening 10 to the 44 times every second. So it's just 10 with 44 zeros every
Per
second. Right?
Movement of that.
Yeah, that's the Planck time. And the Planck length and volume is similarly small. It's
Wow.
beyond our ability to measure with today's technology. But if it were happening at that frame rate, then in some sense, you can use the analogy of CPU speed. And you could say reality is playing out at a CPU speed of 10 to the 44 times per second.
Yeah.
Now, how could you tap into that nearly infinite speed
Yes.
to bring it up to the atomic scale to build computers and devices that can enjoy that ultra high frequency?
Wow, that's just game changing. That is just right away. Whoever, however we figure that out, that is
Right.
that's way more than what we have right now in terms of ability to process.
Yes, and I must say, just to give balance to the other side, the Copenhagen interpretation of quantum mechanics postulates this idea called wave-particle duality, and it says that until you measure something, it is in a superposition, like a ghostly state of being, let's say if it could be at this position or this position, then the quantum superposition says that it's in both at the same time and neither at the same time.
Until it's measured.
Until it's measured. Now, that is an interpretation or a conjecture of the statistical mathematics of quantum mechanics,
So
but
then
there are others.
that Planck could be at 10 to the 44 position.
Well, imagine if this glass were moving back and forth from this position to this position, back and forth, at 10 to the 44 times per second.
Yeah.
Now, of course, you could never measure that. All you would do is you take a position measurement, and you would say, well, at that time I took the measurement, it was here. So I've collapsed the quantum wave function, and until I measured it, I can say, philosophically, I can say it was in both positions at the same time, or neither. That's the wave-particle duality philosophy or conjecture. Or I could say that it's moving immeasurably fast back and forth, which is virtually a superposition, because if I were to move it back and forth infinitely fast, well then that is technically exactly the superposition idea. Infinitely fast, it's in both,
yeah.
it's in neither.
Yeah. Okay, so that's branch 2, and then, okay, so then branch 3 is low energy nuclear reaction. So now so many people understand nuclear energy as in fission, and fission produces waste, and fission produces the non-ideal circumstances for having a long living civilization. Fusion produces what happens in our star,
Yeah.
and what if we could figure out how to do that at the level of just fusing hydrogen together at maybe the cost of $1 instead of the cost of $99, we could take out $99 worth of energy versus just $1 of energy and make it really effective.
Yes.
Forever, and then that would be amazing for us.
Yes.
Well,
So that's a great analogy of the $99, and that's exactly a good way to understand hot fusion. So the nuclear reactors, what they'll do is they'll spend a lot of energy, usually generated by coal-fired electric plants, and they'll use that energy to smash particles together at a very, very high energy and at a high electric cost for your energy. And then when it's smashed together with sufficiently high energy, you can crack open the nuclear energy by getting a fusion event, and then you can harvest that nuclear energy. And so it would be like spending $99 of electricity to smash them together and getting $1 back. Except it's worse than that. It's more like $99.99999, and you're getting back a fraction of a penny. But if you do it enough, repeatedly, then that fraction can add up. And so that is actually a great analogy for the current state of nuclear reactors, hot fusion nuclear reactors. But it's not as economically viable as just scooping soft coal out of the side of a mountain and burning it.
Yeah.
And so what if there were a backdoor key, a way to get the nucleons of two atoms to fuse without forcefully smashing them together?
There is a way to do it.
So that's the idea of the study of low energy nuclear reactions. High energy is is smashing them together. Low energy nuclear reaction is this backdoor, this other way. And so in 1989, Pons and Fleischmann published a paper announcing that they had achieved these reactions. They called it, at the time, cold fusion, because it's low energy.
Mm-hmm.
And it was reported on 60 Minutes. It was a big, optimistic, exciting time, and then it was followed by a crashing disappointment. So what happened is Pons and Fleischmann published it, then other universities reproduced their results sometimes. So the problem is Pons and Fleischmann could not consistently reproduce the results. Sometimes it would happen, sometimes it wouldn't, and some of the other universities had it happen, and then other times they didn't happen. So the literature started filling up with these early reports after 1989, and because with experimental physics, it generally should happen every time, all of the time.
Yeah.
So even though it happened some of the time, it was presumed that there's some glitch in the experimental controls, and that this was all just a false alarm, and that this hope for humanity reported on 60 Minutes of cold fusion saving the world was actually not real, and even some people called it a hoax. But the U.S. government, through Los Alamos and the U.S. Naval Institute and various other government national labs, continued working on it after 1989. And then as we got into the 90s and the 2000s, various university groups, MIT, Stanford, groups in Japan, all around the world continued working. So today, we have about 2,000 peer-reviewed papers in the literature verifying that cold fusion, which is now called low-energy nuclear reactions because the name cold fusion was ruined by the controversy at the time in 1989, but you can call it whatever you want.
Yeah.
Cold fusion is a great, clever,
Fast, yeah, exactly.
nice word.
Yes.
So now it's known only if you're up to date with the literature, you know that it's an accepted anomaly in physics. But if you talk to any physicist off the campus of Stanford or any place, and they're a non-subject matter expert, they will have been exposed to the rumor mill that happened after 1989 and not be aware that there are 2,000 peer-reviewed papers in the literature. So here's the problem. Just because it's an anomaly in physics and known by subject matter experts to be real doesn't mean it can help the world or change the world, because in order to max out on something, to potentiate a physical result, you have to have theory. So we can do what we do with electronics because we understand quantum mechanics and we understand electromagnetic theory. And so through that theory, we're able to max out on how we engineer devices. But what happens if you just have this experimental result of low energy nuclear energy and you don't have the theory, the new atomic theory that allows it to be real? And so you're stuck with this anomaly and you don't know how to tweak it to get something that can compete with coal or oil and really change the world. So that's where we're at now. So there's a big opportunity, a wild card for someone to come along and intuit or deduce what the proper nuclear theory is. And so for us, the proper theory comes from our understanding of studying quantum gravity via the lens of quasi-crystal mathematics. So we are building a very special system of quasi-crystal structured nanoengineering in the topological quantum computer that we're working on. And if we're correct, we really owe the credit to the thinking that we invested over 9 years to think about this quasi-crystal mathematics, which it's really not super complicated. It's just, I would say that there are 50 full-time people in the world outside of our group who work on quasi-crystal physics or math full-time, 50. And maybe another couple hundred who understand it at an expert level. So it's an incredibly arcane and small community, and we're sort of, therefore, the only people applying it to unification physics and quantum gravity, and we're also the only people applying it to low-energy nuclear reactions or quantum computing.
What is the backdoor in cold fusion?
Okay, so to explain the backdoor, you have to understand this idea called quantum tunneling. Okay, so the idea of quantum tunneling is allowed in quantum mechanics, and it says that, for example, if I have an atom here where this glass is, or the whole glass for that matter, quantum mechanics actually allows some statistical probability for the object at the next time you measure it to be here, without ever having traversed the infinity of coordinates between here and here. So that's a weird, magical, counterintuitive fact of quantum mechanics, just like entanglement is a weird, bizarre idea, but it's fully accepted and allowed by quantum mechanics. So what would happen, so you have this thing called the Coulomb barrier, and it's like a force field, like in the Star Trek Enterprise and the Romulan ship. If they were to get too close together while their force fields are on, it would just go vroom when they repel away. And as they get closer, the force field is stronger. So that's the Coulomb force field.
Between two atoms.
Between two atoms. So as they get closer, the force field repulsion gets stronger. So that's why it takes this $99.999 of hardcore energy to just force, to muscle them together. But what if you used quantum tunneling? Instead of forcing them together, it would be like, let's say you have a nice strong wooden door to your office, And you get some physicist to calculate how much power it would take to just smash through that door. And he calculates, well, if you have a 320-pound NFL linebacker and you have him run at 22 miles an hour at the door, you'll smash that sucker down. So you've calculated it. And so you can calculate the amount of energy and calories and kinetic energy that it took. Or you can have an 8-year-old girl just walk right up to the door and use a half a pound of pressure to turn the knob and whisk right through the door. So tunneling is like that 8-year-old girl turning the knob and going through the door using not brute force energy. So here's one nucleus, here's another. I need them to get to within, I need their Coulomb barriers to overlap. Once they overlap, this thing that was this massively repulsive force flips sign value and it becomes a massively attractive force, and then you get fusion, and then there's an energy release. So if I had an atom here, and I could get this atom to quantum tunnel to here or here or here or any overlap, then I could, in a fully legal way in terms of the legality of quantum mechanics, without violating quantum mechanics, I would have a nuclear fusion event without having used energy to smash them together.
How do you get them to quantum tunnel to the point where they break the Coulomb barrier?
Quasi-crystal mathematics and quasi-crystal materials science, nanoengineering.
And just to make sure, the quasi-crystal again is the
quasi-crystal is a particular geometric arrangement of atoms in three-dimensional space that is defined mathematically by it as an irrational projection of a higher dimensional abstract crystal down to 3D. So even though it's mathematically abstract, it's still the way that the atoms are arranged in ordinary space.
In space-time. So it's the way that these oxygen atoms are currently arranged in
whatever the
nitrogen,
atoms are. In a quasi-crystal, it's usually like metal atoms, like palladium or aluminum. Typically.
Okay. And it's the way that they're arranged in that metal that is a quasi-crystal. And then,
exactly. Right. And so your question, I think I can answer it without messing it up, which is, so we have this idea in quantum mechanics and in classic physics about energy wells, energy potentials. And so it essentially says, these water glasses are serving as great props here, so I'm going to use this again. So if this atom is sitting in an energy well here, what that means is that there's these force fields from other atoms around it that, like playing with magnets, for example, that prevent it from being anywhere else. Like if it goes here, this force field here is like saying, oh no, get the hell out of here, you can't be here. And there's another one over here pushing it. And so then the only place it can be is right there. Now, quantum mechanics allows probabilities for it to jitter around to even these energetically inhospitable coordinates, but statistically quantum mechanics says, well, to be here in this difficult repulsive area, it would be exponentially less probable. And so the highest probability is at the bottom of this energy well. So the question is, all right, that's great. So let's say we have this energy well that is this attractive. Let's use a metaphor of a real water well. So a water well, let's say it's 10 meters deep. And so we have this energy well. And so that's where it is, in the energy well, and that's where we measure it, because that's the highest probability. But what if about an angstrom away, there's another energy well, identical to this one, 10 meters deep, and that energy well being the exact same depth as the first energy well makes it equally statistically probable that it can be in that one, because all the particles want to do is go to where it is the lowest energy is, where they can survive, just like with magnets. If you're playing with a bunch of magnets and pointing them in different directions and you put some new magnet in, it's just going to be where it can energetically not be repelled as much. So anyway, so This would require nanoengineering, because you have to get this energy well to be vacant, because you don't want some other atom occupying it. You want to tempt this one
to go into that
to
one.
tunnel to here.
Interesting. Okay.
So we bring it to low temperature, so we know it doesn't have enough energy to muscle through the high energy. Because remember, if this is an energy well, the energy wells are just defined by everything else being too repulsively difficult. So we want to engineer that with nanoengineering, which is the quasi-crystal material science. And then what we get, and this is in the observed experiments within the literature, we get tunneling events of entire atoms, metallic atoms. These are massive objects.
Wow.
And boom, it's like Star Trek teleportation. It's at time 1, it's here, and then at time 2, it just disappears from here, and it's here. It never traveled the distance between.
A full metal atom?
Yeah. Like a palladium atom, for example.
And because you've cooled the environment.
It's not just because, it's not so much that we've cooled the environment.
You've made a 10-meter well next to it.
It's because we've nano-engineered the 10-meter well next to it.
And then repulsed everything else
Right.
away so that it won't fill that space.
And the cooling comes in to demonstrate to ourselves experimentally and theoretically that you can't, at a certain temperature, like liquid nitrogen temperature, you measure this tunneling. Now you can't say at that temperature that this atom had enough energy to muscle through the infinity of coordinates between this energy well and this. It's out, that becomes out of the picture quantum mechanically, and you're left deductively with only quantum tunneling as the explanation. So, even water molecules have been observed recently to tunnel.
And that's a huge step for teleportation in our future.
Yeah.
Ron, what do you think about all of this quantum world life? It sounds crazy, doesn't it?
Well, it will make you go crazy. I think he's doing a very good job comprehending it all and staying sane. But me, when I think about it, I lose my mind.
I feel like a 3-year-old for the first time on this show, like really 3-year-old. I love it. I love it. I need more people to make me feel like a 3-year-old on this show. I love it. Okay, so that's the essence of what you're up to at Quantum Gravity Research. We got a bunch of different branches. It's going to take me another decade of at least daily tapping into quantum understanding to even catch up to anywhere near where you're at. Okay, so let's ask you a couple of our simulation questions. And so, since you're very versed in in this field, let's ask you, what is your definition of time?
Time is change. You can't have the word change without some notion in your mind of time. So at the simplest, irreducible level, the idea of time is the idea of change. Now, change can either be discrete in the pixelated way, where something is here, like on your video monitor, it's just here, and then it's just over here. It never, on your video monitor, covers necessarily all the pixels in between, especially if it's just 2 pixels. Like it's here and then it's here. It didn't have anything in between. So time can be smooth change, if that's your philosophy physically, or it can be this notion of pixelated or discrete change, which would just be an ordered set of frozen things.
Are you Buddhist? Do you follow any Buddhism?
I don't follow any organized religion, but I love the philosophy of Buddhism because it's so...
Likewise.
It's so geeky. It's like the closest thing to physics and philosophy merged.
Merged, yeah. And exactly, not a full subscriber of religion, but I love how scientific it is. Because Buddhism is very much rooted in the idea of time and change being cohesive in that sense, and everything being impermanent.
Right.
And so every moment to moment to moment, there are new photons hitting our faces.
Right.
There's all the biochemical change that's occurring within your body. We're moment to moment getting closer and closer to death.
Yes.
So, okay, that's good. Okay, let's continue onward, and let's ask you about how, and let's within your understanding of what you've been studying within the unification theory, what is then, and quantum mechanics, what is then consciousness?
Well, I certainly cannot define consciousness, and what I find interesting is that no one can define consciousness at a technical level where there's even a 10% agreement within the expert community. So I go to conferences like at University of Arizona, where we have a whole conference that brings together quantum physicists, neurobiologists, philosophers, and they all try to grapple with this question of how is it that consciousness emerges from inanimate matter? What is it? It's called the hard problem of consciousness, and technically, but how can you even have that discussion if you can't even get a solid definition of what consciousness is in the first place? Now, perhaps we can agree on some simple qualities of consciousness without jumping to the conclusion of what it is. For example, consciousness seems to be capable of making a choice. And when it comes to codes or languages, you have to have a chooser. So if you have a C++ programmer in Silicon Valley writing a compression algorithm, well, she has to make choices in the code every time she has a syntactically free step, right, within the rules of her code. And an English language code user has to constantly choose within the rules how to choose, what nouns and verbs to place in these legal slots. And so choosing, if we live in a code theoretic reality, then you're going to need some notion of a chooser. Because of course, if you were to take a random number generator and attach it to the expression of syntactical freedom in some expression of C++ coding language or English, then what would happen is the very purpose of the code would break down, and you'd have gibberish. You'd have gibberish that would be perfectly grammatically legal, no rules are broken, but yet it ceases to even define itself as a language, because a language is defined, a code is defined as a finite set of symbols or objects, rules on how those objects can be arranged, and then syntactical freedom within the rules for the purpose of expressing meaning. So it can be, like with DNA, it can be expressing physical meaning, or it can be abstract meaning, but it has to express meaning. So when you have randomness and code theory, they don't really go together, because as soon as you allow randomness to operate the syntactical freedom in a code, the whole thing just doesn't make sense. It breaks down. It's choosing. So consciousness is this unique ability to choose between vanilla and strawberry. Choosing, right? Not randomly. Choosing with beliefs and rationale and hopes and reasons, purposes.
I like that. Yeah, consciousness is choice. So then let's ask you about the localization of it. Is it then localized in the human nervous system or in the nervous system of an animal?
Well, quantum mechanics strongly implies that there are connections between things that are just now becoming clear. For example, Juan Maldacena and Leonard Susskind, who are very kind of elite physicists, are saying in the last 3 years that space-time is emergent from wormholes from general relativity and quantum entanglement from quantum mechanics, and that the wormhole and the entanglement are actually the same thing with different labels. So that they're implying a kind of cosmic neural network formalism of entanglement / wormholes defining everything, the particles, the space and time around us. And our theory, emergence theory, is also deeply based on entanglement or connections in this quasi-crystal mathematical formalism, which they're called empires. So in a quasi-crystal, if you have a tile here that you exercise your syntactical freedom to make it like this, like in my example where I said, let's say you had the Penrose tiling and you had 5 ways you could arrange it. So any way that you change the arrangement has these radial beams coming out of it that drop in density as 1/r² that are called the empires. That's the tiles that are forced to be on when you choose with your choice this one to be on. And so those empires connect, and we are using that notion to model entanglement. So the gist of your question is, is everything secretly connected at some level that we don't understand yet, or may not understand deeply until we have a successful quantum gravity unification theory? And so I think yes, I think everything is deeply entangled and non-local. So that
non-local.
Because what happens with this principle of entanglement in quantum mechanics is you can have a particle here on Earth that's entangled with another particle. And you can send that other particle to a different time. In other words, you can move it to a different place literally in time, and this was demonstrated experimentally recently. Or you can move it to another position in space. And then if you flip this from, say, spin up to spin down by manipulating it, it will instantaneously flip the other one in another time or another space. There will be no signal that transmits, no notion of the speed of light. It's no speed, it's just instant. It's like if I take a quarter and I rotate this end and then focused on the head side, well then instantly it's rotating the tail side. There is no signal.
The person in front of you at the deli shop ordering a falafel sandwich could then influence the people behind them ordering the different types of sandwiches.
Could influence the people in
Australia,
in a deli in New Delhi who are ordering a falafel or whatever the analog of a falafel is there. And so there would be this secret non-local quantum entanglement connection between everything.
And then that is the potential theory of collective consciousness.
Sure, I mean
that's something that's very interesting.
Yeah,
that the whole this whole planet acts as a bunch of your neurons, my neurons, the animal's neurons are all working together as one Earth neuron going around the star.
Right. I'll tell you, even though we don't understand how to define consciousness, most people would agree, say a materialist, very skeptical, closed-minded scientist would say, I'm conscious. Most materialists don't deny that consciousness is real or that they are conscious. And if you said, well, where did this consciousness emerge? And most would say, well, it has something to do with the neural network of the human brain. And so that's an interesting thing, because in a neural network architecture, we see this enigmatic and difficult to define quality of consciousness floating on an ocean of simpler things. You have these quarks and electrons, photons in your soft matter in your brain, and then there's these emergent structures, the atoms, the neurons above that. And floating somewhere in the ocean of all of that emergent structure, somehow within what is allowed by the laws of nature and quantum mechanics, emerges this difficult to explain notion of consciousness. And so the question is, well, does it have to be a carbon-based neural network within a soft a human brain?
Probably not.
Can it be artificial? Can you do it with silicon? Can you do it with quantum computers?
Exactly.
And what if space-time itself, or all of reality, had mathematically a neural network architecture? Then can consciousness emerge? Is consciousness a general thing that can emerge in the hyper-evolved emergent complexity or high strata, like I talked about, a vastly complex thing like your awareness and your consciousness floating on a hierarchical emergent structure where it's more complex at each level of the hierarchy. And it's so many levels that you can't even track it down. Like science just can't figure out what's in between. But we know that the thing emerged, the consciousness emerged, and we know something about how the fundamental particles interact, and there's this vast no man's land of undiscovered science in between. So perhaps if space and time can be non-local, which now experimentally through these entanglement experiments, we know as a consensus now that this entanglement is real and that it happens non-locally across space and time. And if that is just the tip of the iceberg and it's a giant Planck scale entanglement neural network formalism, then sure, I would be open-minded enough to say that perhaps some strange notion of an uber consciousness, a universal consciousness. It doesn't have to get religious. It can just be a scientifically open-minded possibility where one says, I know of no law of physics that sequesters consciousness as we know it to exist only in the soft matter of an animal's brain.
Exactly,
It may or may not be general, but to be
Yeah.
open-minded, I think, is the key.
The key, yes, yes. Okay, then let's ask about the being alone in the cosmos then, because I think those go hand in hand.
Yeah.
How can the consciousness only be localized in just this carbon-based nervous system of
Sure.
of humans or animals versus the potential lakes of methane on Titan,
Yes.
or potentially in the cosmic spectrum of the evolution of a different planet in the habitable zone of a star. There's so many other alternatives.
Yes.
So yeah, walk us down that path of being
Okay,
alone. And
so let me start off with a synopsis. What my gut instinct and my best logical deductive guess is that reality itself emerges from a mind-like consciousness at a universal scale, and that the mind-like consciousness at the universal scale emerged from the simpler components. So imagine this quasi-crystal code made of pure information. It's abstract. It's within the space of pure information. And then you would say, but where does that simplistic code live? And then you say, well, the simplistic code, which is the simplest thing, lives within the mind of the most emergent, complex thing, which just as my mind is infinitesimally more complex than the simplistic interactions of photons and electrons within my body-mind system. Similarly, this abstract hypothetical idea of this emergent uber consciousness emerged from the simple things. So you can explain every step of the way, let's say, along the way.
from
Now-
a single-celled organism all
Right.
the way to our brain.
So that's linear. Now wrap it in a circle, because quantum mechanics implies that the future can influence the past. There's a lot of very good work and papers on that. Wrap this in a circle and
Okay.
connect the end to the beginning, so that the origin of the beginning is the end and the origin of the end is the beginning. And every step in between is just trivial science,
Yeah.
where you can understand, well, where does DNA come from? Well, DNA comes from this chemistry and quantum mechanics. We understand that. Where does this? So you chase it all the way down. And that is called the Ouroboros model. So the Ouroboros is the symbol that you see in a lot of ancient symbolism of a snake, with the most complex part of the snake as the head, and the most simple and smallest part of the snake, the tail, where it tapers off to being infinitely small. And the Ouroboros connects the complex part into a full circle. Now that's all maybe false, but if true, it's at least logically consistent. It leaves no further questions. You don't stop anywhere in the circle and say, where does this come from? You don't have an ontology like the Big Bang theory.
Interesting, and that's what wraps the Big Bang into the potential
Right.
next worm in the next what happens after you go through a black hole
Right.
and out the other end. Big
Sure.
Bang again. It's a wrap.
Right.
Yeah. Okay.
So now let's talk about whether we're first. So the future, Einstein said that the past, future, and present are labels that are illusionary, that the future, yesterday, and tomorrow are identically real, physically real. And your vantage point being in, say, today, is the only artificial label that allows you to label the difference. In other words, when you think about tomorrow, according to general and special relativity, it exists, physically, ontologically real. And it's even been connected through these recent experiments in 2014 that showed that you can entangle particles across time.
Whether I'm alive to actually experience tomorrow or not, it's real.
Yes.
Yeah.
Right. So, in any event, I want to put out 3 or 4 outside the box arguments to defend the conjecture that humans are the first high technology, high consciousness species capable of leaving their biosphere.
Oh, you put arguments in place that we are the first
Yeah.
high-level conscious beings
Yeah.
that can leave the Earth.
Right.
Out of 13.8 billion years?
Yes.
Wow.
So for your consideration, and I like to go against the grain. So many years
Okay.
ago, it would have been against the grain to say that humans are not the first. And then, as we started realizing the vast scale of the universe, and as we started realizing how life can emerge in ultra hot and ultra cold environments, it started becoming ridiculous to think that humans were the first. And so now,
Okay,
what I'm
let's hear it.
saying
Yeah, let's
is
hear it.
rebellious
The
and
1%,
against the
yeah,
grain. So
thought, yeah.
that's where I like to live.
Yep.
But
Okay.
I also like logic
Yes.
and deductive thinking.
Yes.
So here are my things for your consideration.
Okay.
First of all, I am not suggesting that humans are the first life in the universe. I think that life probably exists on at least every other solar system around every star in the universe.
Exactly.
So let's get that out of the way.
Okay.
Statistically or logically, it's ridiculous to presume we're the first. Now, there are 10 million species on the planet today, and the planet has, the biosphere has existed for 1/3 the age of the cosmos since the Big Bang.
Exactly.
And in that 4 billion years of life on Earth, there have been approximately another 90 million species. So the total number of species is 100 million
yep.
over 1/3 the age of the universe.
Yes.
We understand some things about the fossil record. We generally understand that there's no other animal in the fossil record that seems to have developed abstract thinking to worry about the past, that they didn't pay enough taxes in 2016,
Correct.
and that therefore they're not going to send their daughter to college next year.
Correct.
Right?
Yes.
And to have abstract thinking in the form of mathematics, which seems to be the language that physics is written in, and created iPhones and left the planet and put the Mars rover on Mars. Like, we don't see evidence in the fossil record that any of the other
Although a vast majority of our oceans, 95%, are unexplored, so we don't technically know about the underwater civilization.
We don't.
Like,
But for what we see, that there's a consensus, solid view in the archaeological literature. We see humans being a strange case. That's point number one. Point number two is evolution abhors imbalance. So if you have two animals on the African Serengeti, and one of them is a gazelle and one of them is a lion, and one season a lion brood mutates such that the cubs are a full 20% more intelligent than the average lion. Within just a couple seasons, they will so severely outsmart their prey source of survival, the gazelles, that they will drop the gazelle population below reproductive threshold. They will basically obliterate the gazelle and therefore obliterate themselves. This is nature operates on symbiosis. That means gentle and subtle differences between intelligence, speed, tooth size, etc., within the delicate balance of predator-prey systems all around any ecosystem.
And that's why 90 million species have also become extinct over time, is due to some of these mutations that have caused them to be extinct.
So when they get too fast, too smart, too quickly, the system naturally obliterates them. That is, evolutionary biology, which depends on synergy and symbiosis, knocks them out. So along came this one primate that had a cranial capacity, a brain mass to body mass ratio that was absolutely grotesquely out of balance. There is no animal on the planet, not a dolphin, not a chimp, nothing that has remotely close to this brain mass to body mass ratio. And similarly, there isn't another animal that has the ability to worry about the past and link arcs of story between future and past and this complicated abstraction that humans have. There's a little bit of this ability in dolphins and chimpanzees, but humans,
Yes.
we're grotesquely out of balance with everything else. And so we have dominated the planet.
Yeah.
We have the ability, if we chose to disrupt evolutionary biology in massive ways.
Like we already have with the 1 billion pigs and the
Yes.
1/2 billion cows.
Yes.
And yeah.
So the point is, of this point number 2, is that all around the universe, the objective of a biosphere is not to create an animal that is grotesquely out of balance in terms of its abstract thinking and cerebral capacity than every other atom. The shark is far more evolutionarily advanced than us, but not as abstractly intelligent as us. They have other qualities.
Yeah.
And so we got away with murder. So somehow the biosphere wasn't able, evolutionary biology wasn't able to snuff us out as it should have because we were out of balance. We dominated our spheres of influence.
Well, there
and-
were a couple of those snuffs out with Neanderthals and stuff like that.
Well, we almost got snuffed out in the Cuban Missile Crisis, right? And we could get snuffed out if we use up our resources, because
Yeah.
that's usually how the biosphere snuffs some species out that gets too smart or too fast.
There's other Fermi filters like AI and
Yes.
nuclear war, etc. Yeah.
So I like that Leonardo DiCaprio movie, Catch Me If You Can. So think of mankind and what they've got away with as getting away with murder. And the biosphere, evolutionary biology, doesn't like that. It would prefer to have other things get similarly as intelligent and have us be just a little bit more intelligent, keep things in balance, symbiosis. But we got away with it, and right now if we get off the planet and can get out into populating other regions of space-time,
Yeah.
then the genie will be let out of the bottle, and this particular biosphere would not be able to snuff out this high consciousness abstract thinking. Third point.
Okay, so
Yeah.
so the essence of the second point is that typically evolution will figure out ways, and along with these Fermi filters, there will be a very unlikely hood of the species getting off of the rock.
Right. So
Okay.
now, so I grew up at the time in elementary school where we were worried about the bombs going off, the 20,000 intercontinental ballistic missiles on each side of the Russian and American side being fired on every ally, every country who's our friend or Russia's friend. It would have just put us to a Mad Max world.
Exactly.
Right? It didn't
Yeah.
happen. And now with private space flight and Elon Musk doing his thing and
But
others,
how close was this rock to actually not being able to get to?
it was like a Hollywood screenplay,
Yeah.
like as though it was written for adventure in the nick of time, like a cliffhanger. So it seems that we're getting off the planet. It seems that we may be okay, but it still is shaky. So it's this, how can technology and physics help us to get along better, help to reduce the scarcity theory, right, versus the abundance theory? And so moving on with these points for you to consider. So the next point to consider is
Point three.
Point 3 is logically, it has to happen first somewhere in a universe. So you have the
Okay.
Big Bang. Now, a lot of the years in the 14 billion years since the Big Bang, there couldn't have been anything in the first place because a lot of it was just preparing the stage for a low enough temperature universe. In other words, in the early hydrogen universe, well, you didn't have 81 stable elements
Okay,
at that
so
time.
then let's hypothetically say, what has there been? 9 billion years to do it, or 8
Good.
or
I like
something?
that.
Yeah,
So let's
okay.
take 9 billion as a good number for the discussion. And then let's say that it's a true statement that high consciousness capable of leaving the planet with high technology and understanding the theory of unification, that had to have happened somewhere first. So then the argument becomes not whether or not it happened someplace in the universe first, but whether it was here first or somewhere else
Somewhere
first.
else first, yeah.
So what I advise people is to realize that all of the cosmological models, whether it's the big fizzle or the big crunch or any of the cosmological models, all of these models really plot the universe as being able to be much older than it is now. We measure a human in terms of years. That's a good thing. And you should measure a universe in terms of solar lifetimes. So you see
I like that.
see documentaries and you
like
see
that.
these big celestial dust clouds, and we call those star birthing nurseries, and you kind of get this false impression that suns come and go and there's been many cycles, but this is not the case. Our universe is only about
Interesting.
1.4 solar lifetimes old.
Of our star.
Well, no, the average sun
average
in the
sun.
universe is about 10 billion years old.
If it's about if it's larger than our star or around the size of our star.
Some have a shorter lifetime, some have longer, but if you take the
yeah.
average,
Okay.
it's about, let's say, for sake of discussion, 10 billion years
Okay,
old.
I thought it might be closer to like maybe 6 or less.
It could
but
be 6 or
okay,
less.
sure,
Honestly, I
okay.
haven't done
so,
the
but
average.
2, but basically almost 2 of these like,
Less,
solar.
less than 2, right?
Okay.
If 10 were the average, then it would be 1.4
Okay.
solar lifetimes old. So very young. Now, most of these cosmological models allow countless thousands of solar lifetimes old for the age of the model. So in other words, we are in an incredibly young, early stage of a universe. So that's point number 3. Point number 4 is Carl Sagan. So Carl Sagan, years ago, in the 70s, convinced Congress to give him a lot of money through the NASA program, the search for extraterrestrial intelligence. And he was convinced, based on this reasonable logic, that because there are countless billions of stars and because there certainly must be life on other stars, and he missed the fact that evolutionary biology doesn't like necessarily when one animal gets so massively intelligent. And for that matter, intelligence isn't exactly the name of the game for biology. It's other forms of intelligence, like the intelligence of a shark or a forest ecosystem. Okay?
Exactly, the sustainable.
Yeah.
Okay. So
The ability to thrive and propagate, which
Yeah.
isn't necessarily at all related to abstract thinking ability.
we're making an iPhone. Yeah.
Yeah.
And what negative influences that potentially has on the species,
Yes.
actually. Yeah.
Oh, by the way, if you go to a statistician at a university and you say, hey, can you help me to calculate the statistical probability for something happening like what happened with humans? He'll say, no problem. Tell me your sample size on how often it happened, and then tell me the full universe size. And you'd say, oh, well, it happened once, and it's about 100 million species attempts. So the biosphere played around with 100 million different combinations of the 4-letter code of DNA
Yeah.
and RNA, and it happened once. He would kick you out of the office. He would laugh and kick you out of the office. He'd say, in statistics, we can't take a sample size of 1 against any size, whether it's 10 or 100 million, but certainly not 100 million,
Yeah.
and say with a straight face that this happens approximately 1 out of every. In other words, he says with
Reproducibility.
1 out of 100 million, it may never happen. This may be the first time it happened.
Yeah.
You can't say anything, but it's odd. It only
Okay.
happened once, right? So
We don't have the equipment, though, to be able to look at all the other 6 billion-year-old
No.
star systems and see the
We do not.
planets in the habitable zones.
We do
there.
not.
Yeah.
But the point is, you can't simply take 1 out of 100 million and then say every 100 million stars or a couple 100 million stars, there's likely to be this abstract intelligence, because this may be a fluke, what happened here. And in a very young 1.4 solar lifetime universe, it could
Yeah.
be the first.
I really like your point. Is there a 5? Is there a 0.5?
So the no, there's no 0.5. But
That's
when you
really
yeah,
good,
the
okay.
5 was Carl Sagan. So Carl Sagan
Okay.
got this money.
I thought it was 4. Okay.
Yeah, 4 or 5.
Okay. Yeah.
Carl Sagan looked and he listened, and I'll tell you, he was shocked. Near the time, in the years before he died, he was dumbfounded that they had been listening to the skies in every direction they could point these radio telescopes. They were pointing it all the way to the early universe, time-wise.
Yeah.
They were pointing it in every direction they could point in, and one author said it was eerie, as though you can hear a pin drop, as though we are alone out there. Now that's a few decades of government-funded hardcore experimental listening.
That's also assuming that they have electromagnetism that's pointed in our direction that we can then hear.
Well, if it's happening somewhere, then it goes out like a spherical blast impact underwater. It goes out like that. So
that we have to be pointing there in that moment
yes,
in time. And
we haven't pointed it in every direction to rule it out. But yet, to the scientists who were working on this SETI program, most of them admit that they're a bit dumbfounded as to why they haven't heard anything. It's only, none of these arguments are proof or a slam dunk. But when you take them all together, and you take then you come back to the reasonable question to say, is there any big reason why it can't be us first? Not the first life.
Yeah.
But only the first thing for this bizarre and unnatural thing for an animal to get grotesquely out of balance with the rest of its biosphere.
Exactly. So the likelihood that this is a higher level consciousness, being the first higher level consciousness, is more likely than being the first life. There's likely lots of other first life, single-celled life, plant life, animal life going on. But to go grotesquely out of balance. I really like your points. I really do. I think they're very well articulated and well summarized. That's good.
And the question is, can those descendants of ours, which quantum mechanics and general relativity tell us that the future exists and can be connected to the past, to the present where we are now, the question is, do our descendants speciate from us? Of course they do. And our descendants will speciate from us not with slow evolutionary biology, but with advanced genetics beyond our wildest imagination.
Exactly.
They will be born in other rocks, and they will not have our DNA. They will truly be aliens, and yet they will be descendants at the same time. Can our descendants somehow have any connection with us? Is there some new physics of the future that allows things analogous to teleportation in large systems, remolecularization? Can you move abstract information from one place to another? What is consciousness? Can it exist in the neural network of quantum gravity space-time? Can you navigate that freeway system with your soft matter consciousness? Can you somehow get in there? We don't know, but I would say that if I was forced to believe from personal experience that extraterrestrial contact occurred. Bottom line is, I think everybody has to just have their own opinion, because I don't think any evidence of it is necessarily going to convince. Well, maybe if you had Independence Day landing on the White House lawn or something, but I think that if I were forced to believe that and say, all right, so that just happened, then the more grounded, logical guess of it is that our descendants who discover the deepest first principles unification of everything and go on to have such vast science and consciousness, and maybe they can even group together at will in sort of weird hive consciousnesses maybe. Those beings may use that ability to make contacts with their ancestors back here, and maybe they do it in a certain way as not to disrupt their own timelines. So maybe there's a reason they do it in this kind of mysterious hit and miss kind of way, because doing it beyond the noise, right, in too overt of a way, literally disrupts the feedback loop between future and present.
Correct. So the advanced civilizations that we end up birthing out from this, hopefully, would be so different than us, even 1% genetically superior than us. They will be living with all this new technology and new lifestyles. They could go back and figure out how to interact with us in a way that doesn't affect their future.
Or what if it secured their future? What if somehow the subtle feedback loop between our future and past somehow is why we're discovering, why are we accelerating right now? Like, why this exponential understanding of physics and quantum computing? Why is this picking up speed the way it is, and why now? And what if we're in some entanglement feedback loop with information or knowledge from the future? Now that's weird because you
Yeah.
can't, because the only reason the future has the knowledge is because us back here, the ancestors, worked on it. But if the only reason we figured it out is because we've been in a weird feedback loop with our future. So I suspect something like that may be at play, but it's just philosophical fun until somebody derives a predictable and rigorous quantum gravity and particle physics theory.
Exactly. That's so fascinating. I'm so excited, and you excite me so much about
Cool.
it. Okay, couple last questions before we peace out. How about, what is the most beautiful thing in the world?
For me, the most beautiful thing in the world is the quasi-crystalline spin network. And you can get a feel for what this object is by looking at our movie called What is Reality on YouTube. If you Google what is reality and then just the word quantum, it'll come up as the first listing.
We'll put the link in the bio.
So that object is aesthetically, artistically gorgeous. It's beautiful at a philosophical and heart level for me because it's the very fabric of reality. It's the code.
It's a code of reality.
Yeah.
And that's the thing that wakes you up every single morning and lights the fire under your ass.
That's my play.
That's your play,
Yeah.
exactly. The quasi-crystalline
Spin network.
Spin network.
The QSN.
The QSN. Awesome. Awesome. That's the most beautiful thing in the world. That's a good one. No one's ever said that before. I love it. I love it. Okay, and then how about quick on maximizing human potential?
I really don't like themism. And every time I notice that I'm being ignorant or arguing with a friend or something ignorant, and I calm down, I look back at my behavior afterwards, I realize that I was dropping into the themism, which is about egoism.
Yes.
So we need to protect Americans, American jobs, right? Because them, it's them. And I just think it's a choice. So if philosophically you want to blame and follow the philosophy of themism, then do your thing, you know. But I think that when you find people who are focused on serving others and making the team better, the team of the planet, the team of their community better, somehow it becomes win-win. At the end of the day, every time I see people behaving that way, they have success in their life in one form or another, either financial success or just spiritual, psychological success, relationship success. And when I look at the themism specialists, sometimes they'll amass a little bit of cash, you know, but they end up being unhappy at the end of the day, as though they're chasing after, you know, just like chaff, fluff. So I think that that I see a trend of memes in the world, and I look at this Donald Trump election as the last hurrah, because as a candle snuffs out or some funky old antiquated paradigm dies off, it usually has one last day in the sun, one last just death throll, okay? And so I don't have a problem necessarily with Trump being elected. If I could create history, I would say that that it would be, you know, I would have chosen for him not to be. But I also see it playing a purpose where this last death throll of themism in this cartoon character way, where it's shown for what it is to be just absurdly ridiculous. Just putting it out like the emperor's new clothes. The king comes out buck naked, and it's just, it made the facade of him doing the daily routine of showing off his clothes just a joke, and that joke never happened again after the one day he went out naked. And so I think that we do see this surge, this bulge of religious fundamentalism, which is themism, and conservative ultra-patriotism and ultra-economic territorialism. But I also see that it's not the hip thing. And usually the hip thing is the thing that ends up flowing with the greatest momentum. I see it as a death role.
Yeah.
And I see technology and the understanding of nature playing a pivotal catalytic role. If we can
Absolutely.
have a breakthrough in understanding reality, which is about physics, and the deepest understanding of physics may indeed lead to an unexpected conclusion.
And human spirit probably.
Well,
is
what
in
if
there as
what
well.
if the deepest understanding of physics, through the abstraction of mathematics, as sterile as that sounds, leads to a logically clear realization, an epiphany, that the intuitions of people who claim to get psychic premonitions, or the indigenous people who claim to operate on this navigation of intuition and guidance, or this notion of consciousnesses that are not literally a physical animal with you. What if all of those intuitions turn out to be legalized, validated by some new physics that allows unthinkable new technologies, but also validates the spiritual view, and in some sense shows some of the spiritual stories to be just metaphorical stories, right? Just as it'll show some of the current scientific paradigms to be placeholders and soon to be antiquated thoughts, and there will be this new unification of matter and spirit,
Cool.
if you want to call it that.
I love themism. That is a really good way to put it. That's a great way to explain it. And the opposite of themism seems to be this global cohesion.
Yeah.
It's a much longer conversation to actually dive into the present moment's need for some themism to prosper and guide the rest of the world as the United States potentially,
Yeah.
because we're not quite in the most stable sort of position to
Yes.
be able to say, let's all work together right now,
Yes.
but there's still some crazies going on the
Yes.
planet. So there's a much longer conversation, but
Yes.
overall the idea of themism is
Yeah.
a really good one. It's a good way to put it into perspective. So, and it's a good way to no longer have polarized conversations,
Right.
rather than thinking of them of people that don't think the same way you do as them. We think about it as, this is another human being that has had a different life journey, that has
Right.
had a different outcome than I have. Why do they think the way they do? What can I learn from them? What
What
they
can I
from me-
learn?
from
Yeah,
them?
let every
Yes.
situation and every human be a teacher.
Exactly.
The hardest challenge, how is Donald Trump a teacher?
Exactly.
If you're creative enough,
Yep.
you can find the
Find it
wisdom
out.
in that.
Exactly. And like you said, it could be the last big
Yeah.
of the themism
Yeah.
idea. Okay, and all right, let's do our last question. I want a quick address from you from one before the last one.
Okay.
Do you think there's a global ruling elite?
No, yes and no. So I think a long time ago there were global ruling elites. Everything from the sort of Knights Templar, the Rosicrucians, secret societies, all the way up to Trilateral Commission, the United States government, right? That for a while was the dominant, ruling entity and club, and now less dominant. But the thing is as time goes on, thanks to the neural network of the World Wide Web, which traffics information for virtually free, other than your electric bill, and historically, in order to control, you control two things. You control energy and you control information.
Yes.
So when I was a kid growing up in Los Angeles, we had 2 newspapers, 3 national stations, and and a couple local stations. And if you could control just those few outlets, you could as a corporation, you could control the thoughts. As a government, you could put you could control. Now, forget it. You can't control information
And we kind of
anymore.
see that with media dying in
Right.
its old sense.
Right.
Yeah.
I mean, here you are. You're outside. You're creating fresh perspectives that potentially hundreds of millions can potentially see,
Yeah.
and you're doing it outside of the former systems of media control. So in every way, big and small, we are living in a world that is exponentially becoming decentralized. And the decentralization is if you look at it through network theory or neural network theory, artificial neural network theory, as the system becomes less localized and more connected, then what happens is you diffuse pockets of control, and we're in an exponential networking period.
And that's kind of what's happening with technologies like blockchain.
Yeah.
Yeah.
And so I said yes and no. So sure, there are some last vestiges of pockets of control, but right now the crowd, so as my former life as a businessman, I could manipulate the views of my customers by the quality and the amount of money on my advertising, right? The messaging. And now I can't do that as easily because you've got crowdsourcing on Yelp and others and all kinds of social networks. And the bottom line is people are now going, like, I go to Rotten Tomatoes and Yahoo movie reviews before I spend $12 to see a movie. And I'm never wrong. If I got 5,000 regular Joes on Yahoo that say they gave it 4.5 out of 5 stars, and I got the highbrow critics on Rotten Tomatoes, I never am wrong.
Yeah.
But before, I used to get fooled by the trailers. If it was a snazzy trailer, I'd get fooled, and sometimes it's not representative of the movie.
Yes.
So anyway, so I think that decentralization is on its is taking control and elite control exponentially out of the picture. And in 5 years, we'll be sitting back 5 years from now, looking back today and saying, "Oh my God! In just 5 years, it's so exponentially diffused and minimized that it's on its way out."
Is there also a little bit of benefit of having a couple thousand benevolent people guiding the future of civilization?
I don't think so.
You think all maybe 7.5 billion or 8 billion should be participating in the?
Not necessarily. I see it like a neural network. Like your mind, your consciousness right now is a sort of emergent thing from one part of your brain having this sort of thought form subconsciously, and then another global part of your brain having another thought form subconsciously, and yet another and another. And what comes out is this dynamic and unpredictable consciousness at the surface, above the iceberg level of the water at the tip, which you call consciousness. And so if you think about 7 billion minds, each person worried about a different thing, and then there's groups, like meetup groups, but there's this proverbial groups, and all of the interaction between these different groups. So you talk about 10,000, people in an elite group. Well, sure, you could have 10,000 people working on quantum gravity. So that's one elite group, and they're kind of leading the charge on that. You could have other groups working on, farm to table, more sensible, sustainable ways to get our food. And then overall, the crowd still has to vote and follow the memes and flows.
So that's how it still works, even though there are benevolent people trying to lead the future.
Right.
The people still vote with their feet and their money and where they go with their energy. Okay, all right. I'm loving this conversation. I know it could go on for another hour if we wanted. Okay, very last question is: are we in a computer simulation?
I think that reality, if you have to take 21st century kind of memes and analogies, I think that reality is physically like a neural network, okay? It has the architecture at the Planck scale of what we would call a topological, which means non-local, neural network, and we're not. That's not a novel thought. There are a lot of elite physicists saying exactly the same thing, although nobody has the convincing theory of what the specific architecture of this neural network is. So,
like a collective consciousness.
Well, just because it's a neural network doesn't mean that for sure a collective consciousness has to exist, but it means that you can suggest that it may exist without being laughed, right?
Okay.
Without it being with a straight face. So I think that point me to the question again, because now I'm going deep.
Are we in a computer simulation?
So computer. Okay. Are you a computer? Yes, you are. What's 1 + 1? You just computed that.
Yes.
So you can compute, therefore you are a computer, a computer, right?
Yeah, yes.
But are you a computer in the normal sense of the word? Not necessarily. Computers generally cannot invent questions and generally do not have free will. So what you are is far more than a computer. You can compute, but you can also generate novel and unpredictable questions and syntheses of things that is more akin to the neural network story, where consciousness, remember we talked about how every materialist, most materialist skeptical physicists will say, I'm conscious and I think consciousness is real and I don't know how it works or what it really, how you define it.
And computers could get to the point where they could have these abstract thoughts and be able to...
Well, a lot of people say that that is probably, some people say that's not possible, but that it may be possible with a quantum computer.
Okay.
Because with a quantum computer, you have this non-predictability, because one of the underlying premises is that it's non-determinate, like it's not an algorithm playing out that if you knew all the starting conditions in every detail, you could predict it. So you're unpredictable. Nobody can predict with absolute certainty what you're going to do. You're guided by a neural network and this consciousness. So I think that reality is a sort of mind-like neural network, but we don't have to anthropomorphize that and imagine a god of the collective consciousness with a white beard. It may be more like the Force in Star Wars or the flow of intelligent chi in Buddhism or something like that. But whatever it is, it's more analogous. Because, by the way, the Ouroboros story is logically self-consistent. Every part has a logical explanation. Boom. The computer simulation hypothesis says that we are an advanced quantum simulation in an alien geek's basement at his mother's house, right? And then it leads to the question, well, by that same logic, if we're statistically a simulation in the alien geek's basement, isn't he also a simulation in another universe? And it's called the turtles all the way down problem, which is it doesn't really give you much satisfying explanation. But the Ouroboros story, where everything is emergent and explained by everything else, including the alpha and omega, the beginning and end, is logically satisfying, and there are no logical deal killers in it. So I don't think we're in a simulation. I think that we are in a neural network where the hardware, the software, and the simulation output are all one and the same thing.
Awesome. We could go on about this, and I love your mind. I'm very grateful for you to
grateful to you.
Thank you so much for coming on, Klee. We have Klee's information inside of the bio. You can check it out there. Please go check out the What is Reality video. It's so profoundly interesting. We want to thank River Studios for the pretty beautiful space. Their link's also in the bio. We want to thank Ron Vargas, our director and producer, for doing a great job. We want to thank all of you guys at home for checking this out. Again, I'm your host, Alan Sakin. If you guys had a good time, please give us a like, a comment, a subscribe, share the video with other people. I've never felt like more of a 3-year-old in my life, learning so much.
Sorry about that.
And then again, guys, join us on Patreon. You guys get exclusive content, get access to live events ahead of time, and get access to guest information ahead of time and Q&As. So again, thanks so much for tuning in. Thank you for joining us. This has been such a pleasure. And tune in next time. Thank you.